Hey guys, so let's start to look at families of cubic functions or cubic polynomials. Now we've done families of functions before, so hopefully you remember it's like when they give you a rule that has perhaps one or even more unknowns in there, and it's supposed to represent all the lines or curves that you'd be able to make no matter what that value, that unknown value is. So if we go down here, you can have a look at that, read through that. It's stuff that we sort of already know. With these examples here, I'm firstly going to do one with a parabola, so it's something that we're familiar with or something that we've done in the past. So we might be given this rule here. Now this represents the family of parabolas that have a turning point at this spot here, so 1 and 3. As you can see from this rule, we have a turning point at 1 and 3, but they didn't give us that a value. Okay, so if we were going to draw a graph of that, it could look like that. It could be even wider. Could be even thinner. Could even be the other way around, because a could be a negative number. So that rule there is representing all these different lines, and there's an infinite number of them. Okay, you could keep on making it skinnier, you can keep on making it wider, whatever you like, it doesn't matter. Okay, it represents every single one of them. Now if we look over at a cubic one, which is what we're more so looking at now, this rule here shows us a family of cubics that have these x-intercepts. Okay, so I've put them in already. So one of your curves could look like this. You could have another one that goes even higher, but still has those same x-intercepts. There you go. And again, instead of having it pointing up, that a could be negative, so they could actually have their tail pointing down. So it could go like that as well. That rule is representing all of these different curves and the infinite number of other ones that we can make. Alright, so what's going to happen most of the time in this chapter is, or this exercise, you're going to be given one of those rules. So have a look at this one. They haven't given us the a value, but then normally we just need to find that a value. So if we look at the first question, this is something that we've done a heap of times before. So we have this rule and we've been told that the line or the curve, it runs through this specific point here. If we're given a point, we should be able to work out what the unknown is, or what one unknown is. So 1 point, 1 unknown. You guys can probably guess what we're going to do. Yep, we're going to substitute it in there. So have a go yourself. I'll do it just here. I don't think I really need to explain through it. There we go. So we worked out that a is 2. Remember, or note that it just says find a. So we found a there. It didn't tell us to put a back into the rule. If it had said find the rule, we would have had to write this out, except put 2 in there instead of a. Alright, now the next one. So this is, well, a function has this rule here, and we're told that this curve passes through these couple of points. So this is the family, but we want to find the specific curve in the family that has these details, that goes through those 2 points. So if it goes through those points, we're going to be able to substitute those points into that rule there. So let's do the first one, this one here. Don't like having that fraction there, so I'm going to times it by 2. If I have to times this side by 2, I also have to do the same on the other side. Okay, so there's one rule that we have using that point. Let's use the other point now. All right, there we go. We have a couple of rules. Now, we have a rule that has an A and B. We have another rule that has an A and B. That means we're going to be able to do simultaneous equations with them to find out what A and B are. I might call this one number 1, label this one number 2. Let's try to solve. Now, you can use substitution, you can use elimination. That should actually be a 2 over here. I'm going to decide to use elimination. So I might do 2 minus 1 to eliminate the b. You see how there's a 2b here and a 2b there as well? So that's going to get rid of the b completely. I don't need to change either of these rules at all. So I'm eliminating b. Alright, so 2 minus 1. So 9 minus 3 is 6. Then we'll get our equals. 8a minus 2a is 6a. 2b minus 2b is nothing. So that's the rule that we've got. So a, once we divide by 6, a is going to be equal to 1. Awesome. Now that we have the value for a, we can substitute that a into either of these rules to find out what b is. This rule looks a little bit easier. So I'm going to substitute into that. Cool, so we've worked out that b is 1/2. So we've got one of our answers here. A is 1, and the other answer here, b is 1/2, and we're finished. So those couple of examples, you were just given a rule and some information like as a sentence. If we go over here, I've got a couple of questions where you're not being given the information from a sentence, you're being given the information as part of a graph. So, determine the rule for the graph below. The thing is, this time, we weren't given that rule. So we have to look at the graph and kind of work out what rule is going to help us best. So I can see that this is a cubic graph, but it isn't in our point of inflection sort of form. So our point of inflection form is like that. If it was like that, we'd have to use this rule. But it isn't. It looks more like this, doesn't it? So if it's like that, that means we're going to have to use that other factorized rule because they've told us what the x-intercepts are, haven't they? So it's more so going to be like this. These a's aren't like the same thing. They're not interchangeable. I probably should use a different letter. It could be D, E. It's a bit small there. Alright, now hopefully we can notice as well, there aren't all three x-intercepts, are there? There's only two. One of them has that turning point on the x-axis. So I can actually get rid of that last one there, the last factor there. And because the turning point's on the x-axis, that means one of these factors has to be squared. So I'm going to make that one squared. Alright, so this is what our general rule is going to look like. I might just put it down here so it's a little bit easier to see and use. Okay, let's work out what this E value is and what this F value is, because that's some information that's given there. We know that these show us what the x-intercepts are. We can see what the x-intercepts are here. So I don't know D yet. I'm going to leave D there. This is an x-intercept of -1, so it's not going to be x minus 1, it's going to be x plus 1 in here, opposite. And this one here is an x-intercept of 2, so it's going to be x minus 2. And at the x-intercept here is where it is bouncing off that x-axis, so that's the squared one. Now hopefully you can notice that there's only one more unknown, the d. They've given us another point. If we substitute this point in, the only thing inside this equation that we don't know is going to be that d, because your x is going to be 3, so 3 and 3. Your y is going to be 2, put in a 2. The only thing left is d, so we're going to be able to solve. So, sub in that extra point that we were given. We're finding d. No, y is 2. So 2 equals 4d, so that means that d is going to be 1/2. Alright. Yeah. I was just checking. Alright, so this time it told us determine the rule for the graph. We can't just leave it like this because we haven't given a full rule. So therefore I'm going to show our full rule over here. It's going to be y equals, now our d value was 1/2. We've got x plus 1, x minus 2, and that's squared. Finished. That's our answer. So one more. We've been given another graph. We want to come up with the rule. Now this one looks different, doesn't it? So this one is your cubic that has a point of inflection. So we're going to be more so looking at this rule here. So I'm going to put that rule down here as a starting point. Alright, now h and k, they're our point of inflection values, aren't they? So this is our point of inflection here. These are the values we're going to be able to put in straight away. So I don't know my a yet, I'm going to leave that. Okay, so this is the x value of the point of inflection. The x value is -1. So it's not -1 that we put in here, it's +1. And the y value was 2. Cool, so the only thing we don't know now is a. Now, if we look at the shape of this one, it looks like it's reflected, doesn't it? Because your normal one that isn't reflected has that shape. So we're expecting our a to be a negative number. If it doesn't show up as a negative number, we must have made a mistake somewhere. But we've been given that extra point here. Let's substitute that point in and see what our a value comes up as. So a is -1/2 this time. And it is a negative value. Oops, you can see that. It is a negative value, so that works out. Now again, we had to give the rule, so I want to make sure I'm showing the rule rather than just these values that I've worked out, because I haven't actually given the proper answer yet. So therefore, this is our rule. And finished. Thank you again, guys. Please, if you're having trouble, let me know and I will give you as much help as I can. Thank you. See ya.